Chapter 11 deals with audio production, and one of the basic concepts that you need to understand when working with time-based audio recording and post-production is the idea of an audio file format. Whatever you record or work with in a nonlinear editing environment ultimately has to be saved somewhere, and it gets saved as a digital file that's then transportable from computer to computer or to some sort of an online server for downloading and distribution by whoever's going to consume the media. So it's really important to understand what these file formats are and which ones do you use when you're recording and distributing audio assets for mass consumption. So let's take a look at the two most popular uncompressed file formats that you encounter over and over and over again. And the best illustration I can give you of this is to think about purchasing a professionally recorded music CD from Sony Music or some other company, or downloading a professional music recording from iTunes Store or from Amazon or wherever. That recording is going to be encoded on a compact disc or on the online server, usually in one of these two formats, either WAV or AIFF. If I insert an audio compact disc into my Mac laptop, the tracks on that audio compact disc are going to appear with an AIFF icon, branding them in the Apple Mac language of audio file formats. If I take that same CD and I insert it into a PC with a Microsoft Windows operating system, those tracks will appear with a WAV icon. So really, WAV and AIFF, for practical purposes, you can think of these as nearly identical container file formats. They're just simply the wrappers or the packaging that Microsoft and Apple computers place on top of a digital audio asset. What's really important is understanding what's inside of these packages and how that information gets encoded. So if we were able to open up a WAV or an AIFF file and look inside of it, we would see uncompressed audio bit streams. Those bit streams represent the channels of audio that are associated with the recording. Now, most audio recordings just have two channels of audio, a left channel and a right channel. This is the normal setup for a two-channel stereo recording. More complex programs that might use Dolby surround sound, for instance, Dolby 5.1 surround sound, you would actually have 6 channels of audio for that particular recording. If it was a Dolby 7.2 surround sound recording, you would have 9 channels of audio. So the WAV and AIF file formats simply are containers to hold those individual audio bit streams representing the multiple channels associated with the recording. Now, the standard encoding for digital audio that was set by the Recording Industry of America is LPCM encoding. This stands for Linear Pulse Code Modulation. And the most common situation you will see is 2 channels of stereo audio, left and right, 2 audio bit streams, and the sample rate is 44.1 kilohertz. That stands for 44,100 samples per second at a bit depth of 16 bits. And that is the standard. Now, these numbers can change depending on what your application is and what sort of house rules or distribution variables you happen to be working with. But this is what you will normally see when you are working with professionally recorded music. It'll be a WAV file, AIF file with 2 audio bit streams with this sample rate and this bit depth. So if you take a professionally recorded compact disc and you place that compact disc into the CD tray of your computer and you open that CD up with an application, for example, such as iTunes, which is probably something that all of you are familiar with, iTunes will want to transcode that music as it brings it into the iTunes library. For the most part, we encode music from professional CDs, or I should say transcode them, in the MP3 music format, the MP3 music format, because we want to take that music from the CD and put it onto a portable player such as an iPod. And we want to reduce the file size as much as possible because most people want lots and lots and lots of songs on their iPod. And to be able to get more songs on the iPod, you need to reduce the file size. So over here on the left, as the CD goes into the computer, it goes into the computer as either a WAV or an AIFF file encoded at 44.1 kilohertz sampling rate at 16-bit bit depth. It then goes through the iTunes transcoding engine, where iTunes compresses that music down, often by a factor of 10 to 1. So the output is going to be a file size that's roughly 1/10 of the original. This is lossy compression. This simply means that lots of data from the original recording is going to be thrown out and lost forever unless you save the original recording in order to produce an MP3 file that is 1/10 the size of the original. And so this is what happens in your iTunes program as you're working with the music. And for just a quick illustration, I'll jump over to iTunes. Here in iTunes, I have a single music track that is production music. I can play a little bit of this for you. Okay, this music track is 4 minutes and 1 second long, and if I zoom in here, you can see it's 40.6 megabytes in size. iTunes tells me that the native file format is AIFF. So I can convert this to a different file format should I so choose to do so. And I can do that by going to my file menu and coming down to this option right here called Create New Version. And over in Create New Version, I have one option available to me at this particular time, and that is I can convert this to a WAV file. So I can transcode the container file format without changing the underlying LPCM bit streams by simply choosing Convert to WAV. So I'll go ahead and do that. And iTunes gives me the little chime to remind me that it's gone ahead and done the conversion. And if you notice up here, I now have two versions of the same song. They both have the same title, but one version is WAV and one is AIFF. So there are two different container formats. The file size is really similar. For some reason, the WAV file is a little larger than the original AIFF file, and that's probably just has to do with the encoding algorithm that is used by iTunes to create the WAV file. Well, let's say I want to go ahead and create an MP3 file. Well, to do that, I have to go into my iTunes preferences. And under my iTunes preferences, there's this option here called Import Settings on the main screen. If I go into that, I can choose which encoder will be used by default by iTunes every time I go up to File and I say Create a New Version. Right now it is set to the WAV encoder, and so the only option available to me a moment ago was to convert the AIF file to a WAV file. Well, I can now choose to change that to MP3. And then under the settings, after choosing that format, I can choose either good, high, or the highest quality. And notice that this has nothing to do with bit depth. Bit depth and sample rate really are variables that only apply to the original uncompressed version of the audio asset. What happens when you convert an audio file to an MP3 file, it's going to vary the sample rate and bit depth depending on the manner in which the encoding algorithm is applied. So in this particular case, I'll go ahead and choose the highest quality first. We'll choose 192 kbps, and I'll choose OK. And so now, if I select my original AIF file, go up to File, and I choose Create New Version, I now have this option available to me, Create MP3 Version. I'll select that, and in just a matter of a few seconds, the MP3 file will be created. And here's my MP3 file. And if I zoom in here, you'll now see I have three versions. I have a WAV, an AIF, and an MPEG audio file. These are all three representing the same recording. Two are in an uncompressed file state. The other one is now compressed. So the file size has been reduced drastically from 40.6 megabytes down to 5.6 megabytes. And this is still the same song. Now, whether you notice any difference or not really has to do with how good your ears are and how good the audio fidelity is on the system that you're listening to. If you're listening to this recording through earbuds, the most common way that people listen to portable audio, you're probably not going to notice a whole lot of difference. But if you push an MP3 file through a really, really good sound system, you will notice that it is not nearly as good as the original recording. Now let's do one more thing. I'm going to go back to my preferences. And I'm going to keep my import settings set to the MP3 encoder, but this time I'm going to choose good quality, just to show you again the difference in terms of quality setting, bits per second and so forth, and the file size of the recording. So now if I go down and create new version, I'm creating a second MP3 version of this same recording, but one done at a quality level that's 2 steps below the original. So if we go back over here now and take a look, you can see I have 2 MPEG audio files. The one that I just created is 3.7 megabytes versus the original one, which was 5.6. So by adding even more compression, I was able to get that file size down even more. And what I sacrificed was some quality, some fidelity, in exchange for having a much smaller file to work with.